Okay, so what we're doing here, and if you're a distance student, you don't have to know this, okay? So if you're a distance student, you're not in my section of pre-calculus. But we're doing this because we're going to talk about the things that are due on next class, okay? So I've constructed a grid here. Okay, and the way I constructed the grid is very simple. And I think this is a worthwhile exercise, whether you're in my class or not, but it's certainly not required for this class. So you're welcome to skip this part before I go and talk about functions, domain and range and stuff like that. Okay. Now, usually I don't put numbers in these things at first. And in the pre-calculus class, I don't even know if I'm going to put numbers on, but I think I will. Okay, now what I've done is I've drawn a line down the middle. I put a red dot here. And then this line goes halfway between the left edge and the middle. This line is halfway, that's the right edge, halfway between the right edge and the middle. And this line is halfway between the left edge and the middle. So these lines are equally spaced. They have to be, if they're constructed the way I say. If this is in the middle and this is halfway compared to the middle, then this distance is the same as this distance. And so, okay, now here we do something just a little different. We go to the middle. Now I was a little high on that because I got bad perspective here and I'm being careless. Okay, I want to do a perfect job because it makes everybody feel inferior. Okay, well, whatever. Okay, but this should be halfway between the top and the bottom of the rectangle. And then halfway between here and here, we do another line. Halfway between this line and the lower edge. And then halfway between this line and the lower edge, we do another line. These lines aren't equally spaced because halfway from here to here is less than this, which is less than this, obviously. Okay, then we go halfway from here to the bottom again. And now we want to put numbers in these things. And if you're a distance student, understand what I just said. We're going to say x equals 0 here because we've got like an x and y set of x and y axes. Our x axis is like here. The y axis, draw lightly over the middle line, is here. Now the exercise here is just, okay, if y equals 0 here and y equals 4 here, then what is y equal to on each of these lines? Okay. And people always have trouble with this. So it's kind of a good exercise to think about the numbers and the pictures because a lot of times people don't know how to put numbers with pictures, most of the time. It's true for most people coming into a pre-calculus class. Has to do with the way math education goes. You don't develop any intuition, you just develop a lot of rules. And you get pretty good at those rules, and I think that's important. I think we should be able to do this. Anybody comes out of a high school math curriculum ought to be able to look at this and figure it out. And it doesn't happen. It just does not happen. Okay, so we take a little time to talk about it. Now it's pretty easy once you see it. Okay, so my question is, what does y equal, ouch, on this line? Okay, y equals what on this line? Well, I'm going to tell you, but you know, we have to talk about it a bit in class. Y equals, well, this line's halfway between this and this, right? Here's y equals 0, here's y equals 4. What's that? Halfway between 0 and 4. Everybody knows that's 2. Okay. And now where's this line? So this line is halfway from here to the bottom. So it's halfway from 2 to 0. What's halfway between 2 and 0? 1. Here's y equals 1. And then I'm going to switch my labeling over here between y equals 1 and y equals 0, well, that's going to be y equals 1/2. And between y equals 1/2 and y equals 0, you get y equals 1/4. Now, some people want to put down decimals. I don't want you to use decimals in these for a good reason. The numbers that aren't decimals are much simpler. Because your decimals get down to, well, that's 0.25. If we went to the next one, it'd be 0.125, then it'd be 0.0675, then it'd be 0.03875, okay? And after that, I have to think, okay? I don't use those decimals. Okay, I use the fractions. Because the fractions are easy. It's 1/2, 1/4. After that, it'd be 1/8 and 1/16. And if you understand that, you should understand that much about numbers. And most people don't. Okay, so that's why I have to mention it. Okay, now here we have x equals -2. Here we have x equals 2. Okay, so I give this, and I ask, what's this and what's this? Well, if this is x equals 0 and this is -2, this line was constructed halfway from here to here. You got to stop and ask yourself, how was that line constructed? Okay, then it's obvious. That line's halfway between this and this. Now, if you draw the thing, and then just take the picture and don't think about what you did when you drew it, it's hard to answer the question. And it's hard to bring the two together because, again, our curriculum does not develop that kind of mathematical thinking, although it's easy and obvious. Okay, didn't take much. Okay, so that's why we have to talk about it. Okay, so we have x equals -1 here, because that's halfway between -2 and 0. And x equals 1 here, which is halfway between 0 and 2. There we've got a perfectly good grid. Now we can start talking about this graph. Okay. Now, this graph happens to be one of your toolkit functions. And we want to get this in here before you do what Open Math tells you to do, which is take a calculator and figure out the numbers. And don't think about this, okay? I'm not saying anything bad about Open Math. They made their choice, and the people that wrote that are good people, okay? They're good mathematicians, maybe better than I am, okay? There aren't many, but you know, a handful in the world. Okay, I'm a better mathematician than I was. That's it. At the level I'm teaching, that's pretty good. But... Okay, so now I'm near the bottom. I'm just getting stupid. Okay, now we go from here up to here. There's our graph. And the graph is made by a rule that you don't need to know. You can just take the graph as it is. You'll see where the graph comes from when you do it. It's a toolkit function. Okay. So now I'm talking about stuff that distant students should be focusing on. All right. So this is a function. And we're going to call this function y equals f of x. Okay. So let's pick an x value. Now, I didn't do my stretches this morning. My shoulders are a little screwed up, but I think I know where the board is. So I'm going to close my eyes and I'm going to try to hit that square. Oh man, I nailed it. Okay, there's one of the places. Okay, and I didn't open my eyes. So here, okay, now there's an x value here, and there's a y value here, right? What do you estimate x equals? Now you can use decimals for this, but when you're subdividing things into, and you start with whole numbers, you want to use fractions, okay? you're gonna use decimals. I mean, this is between x equals -2 and this line, which one is what now? X equals -1, right? Good, that's the right gesture. -1. Okay. So here's x equals -1. So write down on your paper, if you would, and if you're a distant student, commit yourself, write this down. What's the x value here? And what's the y value here? Give you just a minute, pause the video. Okay, sharing these thoughts with our distant students, okay? I'll have a little trouble figuring out what x might be here, okay? So what I said, it's between -1 and -2, right? Then I asked, somebody give me a number between -1 and -2. And we can use decimals here, okay? I like the fractions here, I prefer the fractions when we're labeling these because it's feasible. But here, we're just doing an estimate, and we're going to use decimals because we have to understand decimals too. So the first suggestion I had was, what's a number between -1 and -2? Well, -1.5, that's halfway between. I'm good, you're thinking, I'm glad you're thinking halfway. Okay, and you're doing more than halfway thinking. Now, so -1.5 be halfway here. Well, okay, there's -1.5. You just kind of imagine that. You can even make a little mark on your paper if you wanted to. So that's between -1.5 and -2. What's a number between -1.5 and -2? Give me a few numbers between -1.5 and -2. Okay, I'm sorry we can't be recording the interactions. It's very good. People are doing great. Okay, so I asked, okay, here's -1.5. Now, this is between -1.5 and -2. Can you give me a number between -1.5 and -2? Well, first person said -1.6. Second person said -1.8. Third person said -1.75, which is very good, because that'd be halfway between -1.5 and -2, wouldn't it? Okay, now we have to understand numbers this well. We don't absolutely have to, but it's a lot harder if we don't. And there are some students who just cannot understand numbers, but they can understand algorithms and get to the right answer, and they're pretty good at that. Okay, but for most people, and this is what we want to stress, you want to, if at all possible, understand the numbers. There's -1.5, maybe here. So what does that look like? Is it to the right of -1.75 or to the left? Or is it -1.75? What do you think the number is? Write it down on your paper. Okay, so, so after that discussion, we got suggestions of -1.65 and -1.75, okay? Well, I'll usually just go to one significant figure unless there's a good reason to go to two. Like if I think that is really dead halfway, if I divide this interval in half and then divide this interval in half, then I'm going to be at -1.75. That's fine. Okay, I'm just going to say x is about negative. Now, I usually don't write for 0 point, but just to make it more visible, 0.7. Here. Okay. Now, what's the y value? Can you estimate the y value for me? In other words, the place where my chalk hit, I think most of my chalk hit over. I think I see a mark here. That's where I thought I had hit it, because obviously I was aiming at the middle and doing it blind, How about I just wanted to show off. Usually I get closer than that, but okay. The chalk kind of split in two, and at one part certainly good here. Okay, so that's our point. It's a random point. Okay, because it is pretty random. I mean, I'm lucky to hit this whole board. So okay, right. So that's a random point. What do you think its y coordinate is? According to the dotted line that I drew. Okay, now if you're a distance student, I hope you're estimating, you're making your estimates, and I think you're gonna be pretty good at this. But I'm gonna say this is about y equals 1.8, just to go to one significant thing. Okay, said 1.7 or 1.9, that'd be fine. If you said 1.832768 that's what it really is. I can estimate that. Okay. So there, you have y equals 1.8. Okay, so we would say that the coordinates of this point are -7, 1.8. Okay. So we understand, I think, a little better than we did when we came in, the numbers on a coordinate plane. These numbers, simple numbers between 0, 4, and -2 and 2. Okay, now, my question is, what is the value of f equals -0.7? Can you estimate that? Well, you might not know what that means. Okay. Well, this function is y equals f of x. Okay. And f of -0.7 is the y value that goes with x equals -0.7. Now, where is x equals -0.7? Anywhere on this line, right? How many points on this line? Just show me with your fingers. How many points on this line intersect this curve? Just one. Right there. There's no other point on this line that hits that green curve. Okay? That's what I mean by intersects the curve. So I use terminology on you. And if I'd have said, well, how many points does it hit the green line? Everybody would have said 1. Okay, that tells me that I need to explain the terminology. Intersects, okay? You know, this Zoom is making me really kind of nervous. I always look to make sure I'm recording because sometimes I get messed up. And the little thing that shows me it's recording just disappears. I don't keep it on the screen. I'll bet these people can't label these graphs either. Okay, no, these people do. Okay, so we say that, well, that's the point where it's where the x equals -0.7 line intersects the curve. And that word intersect through some people, but now you know what it means. Okay, an intersection where two things meet. Right. Okay. So well, what's your estimate? What's the y coordinate where this line intersects the green curve? Make your estimate. If you're a distance student, make an estimate. We'll be back in a minute. Okay, now just a little number reasoning here, numerical reasoning. Right there is y equals 1/4, right? which is 0.25. And the curve is rising a little bit, okay? It's gonna be a little more than that. So how much more? Well, it's not rising very fast. Here's 0 and here's 1. Most people estimate 0.3. Okay. Some people want to estimate 0.25. I think a little more than that, but you know, if she said 2.7 or something like that. Yeah, it's hard to tell from a hand-drawn curve, though. You can't get all that accurate. You can't get the two significant figures very easily. So I'm going to say y equals about 0.3. There's the intersection point. This line's just a little above the y equals 1/4 line, so we say y equals 0.3. And we really put a little wavy thing above there. Y is approximately equal to 0.3. And sometimes we just do two wavy lines for equal. So we say that f of negative 0.7 is approximately equal to 0.3. And I'm sorry for having to write that so low on the screen. I'm not even sure that that's visible on the screen. Oh, darn, I hit the wrong button. But there it is. Okay. Make sure we can see it. I think Zoom covers up some of the screens. You can always see what we really have. Okay, makes sense? All right. That's one thing to know about f of x notation. The other thing to know about f of x notation is, well, I talked about it in class last time. Let's be sure we understand it. For this curve, f of x is 2 raised to the x power. Okay. Now, if you have a calculator handy, you can punch this in. But, I said x is negative 0.7. I put that 0 in there. And that was really dumb. That probably caused people some confusion. So if you're confused, it's just because I'm confused. It's obviously not 0.7, which would be between 0 and 1, negative 1. It's negative 1.7. Yeah, I think I've got. It's kind of squeezed in there. Okay. So I was just going to do the calculation in my head. Because, you know, power series expansion. And I was going to put 0.7 in, and I realized that wasn't going to work. Okay. So how do we actually calculate f of negative 1.7? Well, if f of x equals 2 to the x, if we replace x by negative 1.7, then this becomes 2 to the negative 1.7, which you can easily punch into a calculator. And I think it is going to round off to 0.3. It's not going to be exactly 0.3. It's not going to be exactly anything that you could even write down because it's a decimal that goes on forever. No repeating, no plan. Okay? That makes sense? That's the idea of function notation, and that's how the function notation relates to the graph. Okay. Now there's another thing that we can do with this graph, and I'm going to phrase it in terms of function notation. We don't need this. Just clear out this little big screen. Solve the equation. F of x equals 1.8. Now, what do I mean by that? Well, I have to explain it to you, because you're probably not going to make the jump. Okay. F of x equals 1.8 means if f of x equals 1.8, then since y equals f of x, we find the point on the curve where y equals 1.8. So can you locate that point on the curve and estimate its coordinates? You already know the y coordinate, it's 1.8. Where does that line, y equals 1.8, intersect the curve? Now, if you're a distant student, I just gave a hint. If you've already made your estimate, fine. You can go on to my next statement, but I gave the hint, well, can you mark the point where the y equals 1.8 line intersects the green curve? Okay. Okay, now, if you look at my graph, you're gonna see there's a point where the y equals 1.8 line intersects the curve, right? And you can mark that point. On my graph, it's going to be about here. Now, when you make graphs to make estimates, make them a little bigger than most of you have made them. Unless you're really neat, some of you really are, okay? And also, you probably want to take a note, put that y equals 1.8 line in there because it reinforces the idea, okay? And when I do the y equals negative 1.7 line, sketch that line, sketch them when you talk about them because it reinforces the idea. But I think you've got the idea. Okay, so there's where the thing intersects. Now, you can draw the vertical line through this and estimate x. Okay, so draw the vertical line and estimate x. You can get x equals I would say 0.7 or 0.8. Since one of you estimated 0.7, I'm going to be contrary and estimate 0.8. Just so you don't go getting a big head. Okay. Fair enough. We see this? Because that's central to understanding all the stuff we're going to talk about related to graphs and related to these functions. Okay? Okay. Didn't need to start. Okay. So we have f of x equals 1.8. We say estimated solution is x equals 0.8. Okay, now you can see how accurate we are by taking calculator app on the phone or whatever, and calculating 2 to the negative 1.7 to see how close we get to 0.3. Our estimate here, okay. And by taking 0.8 and plugging it into this formula and seeing how close the result is to y equals 1.8. And it's going to be fairly close. Okay. With this curve, if you draw the thing carefully by hand, you can come up with something that allows you to make some pretty accurate estimates. Now we're going to learn to do it using algebra. Okay. And the algebraic solution to this is something you don't want to see right now. Okay, because this is a function we don't deal with until we're about 2/3 of the way through the course. One of the most important functions that we do deal with. Okay. Now there are things that we can say about this function. So in 4 minutes, I'm going to say all kinds of things. Okay. I'm going to say the domain of this function. Is the interval from -2 to 2, the x interval from -2 to 2. Okay, because every number from -2 to 2 corresponds to a point on the curve. That's what domain means. Now there's other things you have to know about domain. That's a picture of what we mean by domain. The range as sketched is 1/4 less than or equal to y less than or equal to 4. Because there is no point on this curve where y is less than 1/4. Now, if you extend the graph, it's going to continue going down. And if you extend beyond the domain from -2 to 2, you will get values that are less than 1/4, right? But as sketched, the range goes from 1/4 up to 4. And every value from 1/4 up to 4 corresponds to a point on the graph. Okay, so we just draw horizontal lines starting at 1/4 and going up to 4. We always intersect the graph. That's the fundamental meaning of range. Now there's algebraic definitions and there's also interval notation that you saw on the introduction to MyOpenMath. Okay. So call that the interval from -2 to 2. So the x interval is this, the y interval is this. You'll see that notation when you get to the assignment, okay? So we've seen a little introduction to function notation in a way that I think should pretty well complement what OpenMath is going to tell you. All right. We've seen how to construct one of these graphs. And OpenMath is going to pollute your minds with some other graphs, unless I change the assignments order a little bit. And I might just do that. I'll think that through, especially if I can figure out what the assignment schedule is for the students in the distance section. I've sent out emails, but not everybody checks their email between Wednesday night and Thursday morning, okay? Yeah, busy with other things like sleeping and getting up and getting ready, and some of the class are going to work, whatever. So I don't necessarily expect a quick response. Okay, well, that's gonna have to do it for today. I never know what we're gonna do in this class until I see what you need, okay? So it's not exactly what my tentative plan had been, so I'm gonna change your assignment schedule just a little bit, but for the distance students, I'll find out what I find out and then we'll see what I do, okay?